With quantitative research or experimental research, we manipulate one or more factors and observe the effects. The application and the maintenance of the control. There are controls. Experiments are conducted in a controlled environment under controlled conditions so as to account for any alternative influences on the measured behavior. There are 4 general characteristics that unify those who conduct experiments. You start with some purpose, question, or hypothesis. You control the occurrence of events, so to observe changes in behavior when best prepared to make observations. So you could say for a fact that yes, it was the independent variable that caused this effect on the dependent variable. The experimenter or others can repeat these observations under the same conditions. That goes back to our methods section, so that your experiment can be copied or done over again by another researcher. And you can systematically manipulate certain conditions so as to measure the effects of the manipulations on the behavior. There's a classification of different types of experiments based on the structure of the independent variable used, the number of independent variables studied, the number of manipulated values on the independent variable. But not every experiment falls into exact niche. So we're going to talk about the names of different studies with one independent variable or more than one independent variable with different parts, different values of independent variables being categorized. The first one is a bivalent experiment where you have 2 values of one independent variable measured on the dependent variable. So by 2 values, bivalent experiments. The independent variable is manipulated in a manner that allows for 2 values of the independent variable to be presented to the subject. So 2 values. This is valuable in examining the effects of categorical independent variables, but it's limited in scope, and it may even lead to erroneous conclusions when the independent variable is continuous. So you can only use this with a categorical variable. Here we go. Here's an example. On our independent variable y-axis, we have condition A and condition B. The results of a bivalent experiment showing the effects of child-focused materials on school-related talk of preschool children. So condition A has child-focused material and condition B is not child-focused. The independent variable is the material sent home with the children, and the dependent variable is the percent of school-related talk. So one independent variable, but there are 2 types of it, child-focused and not child-focused. And we're measuring the effects on the one dependent variable. So bivalent experiment, 2 categories of one independent variable. Here's another one. Cochlear implant condition is the independent variable. It could be either turned off or turned on, and we're measuring the percent correct vowel production as the dependent variable. So manipulating the independent variable and measuring the effect on the dependent variable. So presenting only 2 values of a continuous independent variable may not be as clear as presenting a larger number of values of the independent variable, in which case we would do a multivalent experiment, where you have several values of the independent variable on the dependent variable, also called many values. So if your independent variable is continuous, it has many variables that we're measuring on the dependent variable. The independent variable is manipulated so that at least 3, usually more values of the independent variable are presented. When the independent variable is continuous, the multivalent experiment is more appropriate than a bivalent experiment. So a bivalent experiment is most appropriate when you have 2 categories of one independent variable. It gives a broader picture of the relationship between the independent variable and the dependent variable. Because the experimenter samples a range of possible values of the independent variable more completely. It broadens the picture of the functional relationship between the independent variable and the dependent variable. It's more comprehensive than type of experiment for studying functional dependence when you have one variable or another. So with a multivalent experiment, we again have one independent variable, but different levels of it. different values of it. So for example, in these figures, you have the independent variable again on the x-axis, and you are looking at 4 values of it, not just 2, 4, on one dependent variable. Again, 4 values of an independent variable on one dependent variable.